morning, students. As we found in the previous class about refraction through a prism, and there we derived a result also. I hope we have gone through it. That what formula we can we derived in case of the refraction through a prism in the previous class. That one we have finished. Today also we're discussing another topic that is also related to prism. That means we are studying constantly about prisms and its importance in the ray optics, and especially in case of refraction of light from last 2-3 classes. I hope you have got a brief idea about prism, and today's topic will also be related to prism, that is dispersion of light by prism. Dispersion of light by a prism, or dispersion of light by prism. You can note it down. Dispersion of light by a prism. So what does it mean actually? We everyone have a basic concept about white light. That white light is consist of its 7 basic colors, or 7 constituent color. Those were in shortly we can say PIBGYOR. That is it's called PIBGYOR. We know this, starting from violet to red. So P for violet, I for indigo, B for blue, G for green, Y for yellow, and then your O for orange and R for red. Like that, there are 7 colors in the white color. So once a white light is incident on a prism, then what happened? It split it into 7 colors. Are you getting my point? If a white light is incident on a prism, then it's split it into 7 colors. This particular phenomena is simply known as dispersion of light. Is that clear? So once a white ray of light will be incident on a prism, it will split it into 7 colors. I have just told you what are the 7 colors, starting from violet to red. So if I make a prism like that, in order to understand these things, what does actually it is. So if I make a prism over here, say this is a prism. This is a prism, and here if a white light is incident somehow, suppose a white light has been incident on it. This is the white light I have said. This is white light. A ray of white light has been incident on the prism. Then what will happen, as I told you just now, that this white light will be splitted on into its 7 colors. And what are those 7 colors? 7 colors, if I write, this will be like that. If I, it is PIBGYOR, PIBGYOR. See, I have written from the bottom of it. This is PIBGYOR 1, 2, 3, 4, 5, 6, 7. That means a white color is consists of those 7 colors. P for violet, I for indigo, B for blue, G for green, Y for yellow, O for orange, and R for red. This is simple thing everyone knows, but there are a lot of technical things behind this particular topic, that is dispersion of light by prism. So in this case, once I have written this ray light by this order, so you can have an idea about it, that we have got a basic concept about wavelength and refractive index. Wavelength and refractive index. What is the relation between wavelength and refractive index? So if I go to set up a relation between refractive index, wavelength lambda and refractive index. Refractive index we have studied in the previous classes. I have told you these are very basic things. So wavelength also we know what is wavelength. Now if you set up a relation between wavelength and refractive index, you will find that this refractive index mu is inversely proportional to the wavelength. These things remember. Okay, this refractive index mu, that is inversely proportional to the wavelength lambda. Am I clear? If refractive index increases, lambda decreases. If lambda decreases, refractive index increases. So this is an important relation between mu and lambda, I have told you. So in this case, if you find out that this arrangement has been done on the basis of their wavelength, that means in this case the wavelength of red color will be more than wavelength of violet color. Understand? If this has been made in such an arrangement, that means it has been arranged on the basis of their capacity of the wavelength. That means this red has got maximum wavelength and the violet has got the minimum wavelength. That means, can we say that if the wavelength of red is greater than this is not mu, this is lambda. Wavelength of red color is greater than wavelength of violet color. So can we say by this particular formula, as we found, that mu is going to be inversely proportional to wavelength. So I'll write that mu of violet will be greater than mu of red. These things remember. Lambda of red color is greater than lambda of violet color. So by this particular formula, as we found that mu is inversely proportional to the lambda. So in this case, mu of violet color will be greater than mu of red color. That means refractive index of violet color will be greater than refractive index of red color, which will depends upon the deviations of the ray of light when it will passes through the prism. So in this case, one thing you remember, more the refractive index, there will be maximum deviation, and lesser the refractive index, the deviation will be lesser. That means, can you say that once this particular white ray is incident on this prism, what was its exact direction? Its origin direction was this way. It should have gone this way. Is it correct? It should have gone this way. This was its origin direction. But this will not happen, as you know. And why it will not happen? We have also discussed these things. So in this case, what will happen? Since this white light is coming, so it will bend like that. This will be bend like that. Okay? This will bend like that, and this will bend like that. Understand now? They're bending in this process. That means instead of going this way, they are taking this alternative path once they got through the prism. Okay? And after that, there will be dispersed like that, split in some way like that. Have you got it? So these are the direction of them. In this case, I will refer that this is the red color and this will be violet color. Why this is red color and how can you come to know that this is red color and this is violet color? As I told you, as you can see, the deviation and amount of deviation of violet color is maximum in comparison to the deviation of this red color. That means violet color has been bent more. Violet color has bent more in comparison to red color. That means, can we say that violet color has bent because refractive index of violet color is more than refractive index of red color. Red color has lesser refractive indexes, mu is less, so it has bent lesser. But violet color has maximum, more refractive indexes in comparison to red color. That's why it has bent maximum. So violet color will be at the bottom of it and red color will be top of it. In between them, like that, this will be their required remaining 5 colors. So if I name them, this is going to be your indigo, this is going to be your blue, this is going to be your green, this is yellow, this is orange color. Understand? So like that things happens once a white ray of light incident in a prism. Okay, so you can write the definitions of dispersion. What does you mean by dispersion of light? Once a ray of white ray of light, once a white light or once a ray of white light is incident, when a ray of white light is incident on a prism, it split it in 7 colors. Those 7 colors are violet, indigo, blue, green, yellow, orange and red. This particular phenomena is called dispersion of light. And in this case, I have made the colors arrangements from the top of it on the basis of their wavelength. That means red color has got maximum wavelength and violet color has got minimum wavelength. That means I am writing that the lambda of R is greater than lambda of V. As we found one more relation between lambda and mu, that is refractive index. So mu is inversely proportional to lambda. That means if lambda increases, mu decreases, or if lambda decreases, mu increases. So this is, in this case, red color has got more wavelength, so it is getting less refractive index, and violet color has got more wavelength and it is getting less wavelength and it is getting more refractive indexes. One more thing you can say, that this violet, the color with maximum refractive index will bend more. This is the example of it. The color with lesser refractive index will bend lesser, this red color. I hope you have cleared these things. So this is called the dispersion of light once it passes through the prism. Understand? So there are so many things to be discussed. I will come one by one. First of all, you please note it down. I am again telling the dispersion's formula, that when white ray of light is incident on prism, it's split it in 7 of its color, and this phenomenon is called dispersion of light. So I am just rubbing now these things. If I rub these things, if I rub them, so along with dispersion, there are 2 more things comes through you, that is angle of dispersion or dispersive power. Angular dispersion and dispersive power. That is angular dispersion. Angular dispersion we'll discuss now. What is called angular dispersion? So angular dispersion we'll discuss now. What is angular dispersion? One more thing to discuss after that, that is your dispersive power. So what does angular dispersion means? We can write, it is defined as the difference between angle of deviation okay, it is defined as the difference between angle of deviation of 2 extreme color okay, of 2 extreme colors. Am I clear? So it is defined as the difference between angle of deviation of 2 extreme color on that particular phenomena. So extreme color means, if I want to say that what we have got, that this is, if I make the arrangement again, this is PI BZYOR. So those are the colors. Extreme color means if we take the red color and violet color as extreme color. Since we have got that this red color has got a minimum this red color has got maximum wavelength and minimum refractive index. This violet color has got minimum minimum wavelength and maximum refractive indexes. So in this case, if we take that these are two extreme color, if we consider, so it is defined as the difference between angle of deviation of two extreme colors. So extreme color means it is expressed as, it can be expressed as theta is equal to angle of deviation, how much it has got deviated, and deviations is depend upon the refractive index. So I can write that theta is equal to delta of red color minus delta of violet color. This will be the angle of angular dispersion. Angular dispersion will be expressed as theta is equal to del of r minus del v. That means del r means what? Angle of deviation for red color, and del v means angle of deviation for violet colors. This is how we express the angular dispersion. As I have given, it is defined as the difference between angle of deviation of two extreme colors. So this is theta is equal to del of r minus del of v. This is angular dispersion. So after that we'll go to one more topic, that is your angular dispersion. What does angular dispersion exactly mean? Angular dispersion. Angular dispersion. Angular dispersion is what? So again we'll come back to the topic where we discuss in case of what theta, that was our angle of angular deviation, angular dispersion. Sorry, it is not angular dispersion. Angular dispersion we have already done. This is dispersive power. Dispersive power. What does dispersive power mean? We have studied already angular dispersion. Okay, so dispersive power means what? It is defined as the ratio. It is defined as a ratio of angular dispersion to mean deviation. Okay, it is defined as the ratio of angular dispersion to mean deviation of the spectrum, mean deviation produced by prism. Okay, mean deviation produced by prism in the spectrum. Spectrum, you have understood, it is a combinations of all these 7 colors when it comes together. It is spectrum. So you can say that it is defined as the ratio of angular dispersion to mean deviation produced by prism in the spectrum. Okay, spectrum means what? That when you can see that on that case, that when you got the prism and white light was incident on it, and after passing through the prism, there are 7 colors came out together. The whole this arrangement of those 7 colors you can say as a spectrum. That means dispersive power. Dispersive power will be defined as, it is defined as actually by omega. Okay, it will be expressed as omega is equal to what you can say. It is the definition of defined as ratio of angular dispersion. What was angular dispersion? We found as theta. Okay, angular dispersion to mean deviation produced by the prism in the spectrum. Mean deviation. The mean deviation means in the spectrum of that 7 colors you have found starting from red, orange, yellow, green, blue, indigo, violet. If you can consider in this case that the green color is at the mean, or not, green color is right at the middle of all these 3 colors. So from that point of view, green color should be the mean deviation. That means the angle produced by this green color's dispersion will be a mean angle of deviation. Am I clear? Mean deviation, mean angle of deviation. But in this case, this green color will not be considered since this green color is not dominated. Remember, this green color is not dominated. Am I clear? Green color is not dominated, so we'll consider this yellow color as the mean color. Why? Because yellow color is comparatively more dominated in the with respect to this green color. That's why, in spite of this green color is at the middle of these all 7 colors, we will not go for green colors, we will go for this yellow colors. So we'll write that angle of deviation for yellow color. That is angle of deviation, that is mean deviation. That means the angle of deviation for a yellow color will be considered as mean deviation. Why? Because yellow color has got more impact on the spectrum, or it is more dominated color in comparison to green color. Have you got it? So nobody should be in confusion. So why this green color is not the mean deviation or mean color? So will not, because this green color is not dominated, and yellow color is more dominated than these 2 colors. Understand? So we'll have that dispersive power omega is equal to theta by del of y. That means we can write omega is equal to, what does theta means? Theta we found as, theta was your angular dispersion, that was del of r minus del of v. So I'm gonna put it del of r minus del of v divided by del of y. Understand? So this is going to be your dispersive power. Remember, this is dispersive power. The dispersive power is omega is equal to del r minus del v by del y, where del y is mean deviation produced by this spectrum, produced by the prism over the spectrum, and this will not got, of course, any unit. It is independent to unit because it is a ratio. So this was all about your dispersion of light by a prism. It's very simple thing we have discussed. The most important thing is your dispersive power and angular dispersion. And for mean deviation, as I told you, you should remember these things and you should not come in any confusion related to this particular topic. In the next class, we'll discuss the remaining part of this particular concept. If you have any particular doubt, you can inbox me. I will try to come back to you. Till then, thank you so much.